It's exactly 3. Time to get started. So hi, everybody, and thanks for coming to my talk. I'm very excited to be giving this talk. This is a new thing that we actually released and built of this year, so it's brand new. It's the very first time that I'm talking about it, or to my knowledge, anybody else. It's also very cool to be talking about something that I did most of the work on, or at least like there was an inter-team collaboration, but I spent a lot of months this year working on this particular project, so it's cool that I'm talking about it. I'll be using the acronym MEVD all the time in this talk. That refers to Microsoft.Extensions.VectorData, the object or subject of this talk. Don't get confused. Quick show of hands, who here has already used the vector database in some capacity? Okay. Decent amount, but then don't worry. So this is not a super deep dive, advanced wizardry, black magic kind of talk. It's actually fairly entry level. I'm first going to start with a 15 to 20 minute sort of introduction, what vector databases are, exactly what they're used for, that kind of thing, and then we jump into an actual code demo, which is what I like to do. But I also think it's important to kind of bring everybody to the same level and understand everything. So before we get started, this is kind of blinding. So I'll just stand over here, I think. So before we start, a few words on who I am. So my name is Shay Rojansky. I work at Microsoft for the .NET Data Access team. That means that a lot of my time, most of my days, I spend on EF Core. I'm part of the team that actually maintains and works on EF Core. I've got a talk tomorrow, if you're interested, that does a real deep dive under the hood kind of thing, black magic and sorcery, like the thing that's not in this talk, that's tomorrow. If you're interested, do come. But this is not that talk. It's still a very good talk today, but it's a different kind of talk. So I work on EF Core most of my time, or on other like database access components in the .NET stack, like system data and various other things. I'm also, in my spare time, I kind of maintain / own NPG-SQL, which is the Postgres driver for .NET, and even more than that, the EF Core provider for it. So chances are, if you're using Postgres from .NET in any capacity, you're going through components that I work on very actively. It's super cool to be seeing Postgres also demoed here. You know, Postgres is one of the more popular databases and becoming increasingly popular, obviously, and that it's important. So my work on that is very important to me as well. Recently with AI, of course, vector databases have been a major concern of mine. We'll talk, that's the focus of this talk. I'm also very much into perf, but perf in my domain means very different things. Sometimes it means actually optimizing SQL rather than traditional, let's reduce some allocation. So it's a very wide, perf is a very wide kind of thing, and we have a tiny bit of perf in today's talk. Tomorrow's talk is much more about perf. I'm a Linux guy originally, so I really come from command line Linux, Postgres kind of world. I didn't like Microsoft very much back in the 90s and Windows. I'm from that part of the world, which is kind of weird considering where I am. I've been at Microsoft for 7 years now, but it's a different Microsoft nowadays, thank God. I'm also on loan. If you look over there, you might see that this is a bit embarrassing for me, but it's a temporary situation. It will be rectified at some point, and I'm based in Berlin. So let's jump in. Once again, we'll start with a quick introduction to what vector databases actually are, and then we go into the code and see what MEVD looks like. So vector databases, at their core, it's a very simple idea. These are databases that specialize in storing a very large amount of vectors, and doing that efficiently. So a vector is nothing more than a string of numbers, typically floating point, but that's all that it is. Sometimes it's a scary word that sounds like it comes from math. It really is only an array of numbers. That's all that vectors are. And what these databases can do, they can store large amounts of these, and of course, usually with some attached metadata, because the vectors themselves are frequently not that interesting. Of course, storing is not that interesting either. The whole point of vector databases is typically that a vector database can perform very efficient similarity search. And that means the vector database has whatever millions of vectors. We can go to it with a new vector, and we can ask for the 3 most similar vectors to this new vector that I'm giving it, and it will be able to answer that query very, very quickly. It's a similarity search. That's kind of like the key concept here. The way that they can do this is by using indexing. So they have very sophisticated indexing methods. This is also, I'm not deep diving into this, but for example, if you think about it for a second, what does it even mean for 2 vectors, 2 strings of numbers to be similar? That's actually not a simple question. If you're asking about 2 numbers, then we can just subtract them and say, That's the similarity measure. That's pretty typical. Strings are already a bit more difficult. There's something called Levenstein distance. There's various ideas of what distance between strings is. With vectors, again, it's not very clear. That's a thing that needs to be thought about, and there's various competing ideas. Cosine similarity means measuring the angle between the two vectors. Dot product is a completely different thing, and you would choose a different similarity measure on what it is that you're doing. I'm not going to be talking about that in this talk. Then there's, of course, the indexing methods. So you don't have to use an index when doing a vector search. You can brute force it. So then your vector database has to go through a ton of vectors in order to find the closest one based on your chosen similarity method. Typically, that's not what you want. So one very, very almost universally popular algorithm is called hierarchical neighbor small world, which is quite a complex idea, which I don't fully understand personally. It's a multi-layered graph approach to creating an index. Try thinking about this at home. How would you solve this problem? Like in terms of how would you index n-dimensional vectors? It is really non-trivial, and it's very fascinating, but we're not going to go into this. Microsoft specifically also uses disk ANN, both in SQL Server and in Cosmos DB. So indexing is also a whole thing. You parameterize the indexes, you tweak them. There's a lot of decision choices here. One property of vector databases, which I find interesting, so I'm going to mention it, is that index-based similarity search in vector databases is typically approximate. This is weird. Usually in normal databases like a SQL database, an index never, ever impacts the results of your query, right? All an index does is make it go fast, right? You can remove the index or add the index, same results. With vector databases, because of the complexity and what indexing actually means, you're making a trade-off. Typically, you will be trading off accuracy, a little bit of accuracy, for performance. And that's almost always okay because we're dealing with a fuzzy domain in any case. Things are not completely precise when we're dealing with these vectors of floating point numbers. So a 100% accurate result is usually not what you're looking, you don't care, basically. And you'll see why in a second once we start talking about applications. So it's an interesting property of vector search. I just thought I'd highlight it. Now the vectors themselves are not that interesting. They're just a string of numbers, right? So what do we actually do with them? Now we're starting to get to where AI is sort of interesting. It turns out in today's world, you can have something called an embedding service, which means that you can take text, you give it text as input, or any other human thing, content, but let's concentrate on text. You give it as input, and what you get out is a vector that in some magical black box way represents the meaning of that text. So this is absolute magic, and I personally have absolutely no idea how that works, and you don't actually need to understand how it works. These are services that you call into in the cloud or maybe in a local model with Olama. It's just another AI sort of service. It's not an LLM. This is not a chatbot kind of relationship. It's something that knows how to convert text into a vector. A vector, string of numbers, which represents the meaning of something, is referred to in this world as an embedding. That's just a terminology thing, and you'll hear me using that word. An embedding is nothing more than a vector that in some way captures the meaning of some input that was given, okay? So you're starting to understand maybe how this all is connecting together. If we take a lot of texts, maybe it's our product catalog or the descriptions of products in our product catalog, we can pass them through this vectorization, I'm going to use that word as well, which is the process of generating embeddings from the input text. We can vectorize our product descriptions and feed them into our database. And at that point, we can do the similarity search based on all the indexing and all the good stuff we discussed before. And what that means is we can now search for texts which are similar to some other text. And another way to kind of visualize this is if we take the words dog and puppy here, and we vectorize each one of them, here we have a two-dimensional space just so that it works well with our measly human brains, right? But the reality is much higher dimensionality. But in 2 dimensions, we will get back 2 vectors which are almost the same, which are very, very similar. So they kind of form this sort of cluster here of meaning around these four-legged animals that go woof woof. Whereas if we put coffee in there, we'll get a vector that points to some other area that clusters with tea, so beverages, right? So we're starting to see that there's a vector space here, n-dimensional vector space, that somehow corresponds to human meaning. It's all very mysterious and very cool and actually very useful, and we don't necessarily have to understand the math behind it in order to use it in our actual applications. That's important. So you don't need to be afraid of this whole domain. I want to go even more, so we understood what the database is. We now understood what kind of data we want to put into it, but what actual user-facing applications, like what is the point of all this exercise? What am I going to build with this? So who here has implemented some form of RAG? Okay, pretty decent. Yeah, that's interesting to hear. So I'll go through two end-user applications here quite quickly. The first one is easier. It's called semantic search. So semantic search is super simple. Somebody comes to your eShop. You've got an e-commerce solution in the website or whatever, and they type a product like let's say boots. And then you've got your product catalog and you want to search for boots or shoes, whatever, it doesn't matter. So a very naive sort of software engineer will simply use something like SQL Server or Postgres and will use a native like, right? They will just search for the word inside the product description. So that will fail if the user, for example, searches for shoes, but the product description has the word shoe, then that S over there will fail it because we're doing a simple character search. Obviously, we don't want that S to fail our search. So that's too primitive, this character by character search. Now, since decades now, all of the databases that we know have some sort of so-called full-text search. This is a specific feature in practically all databases for doing exactly this, so searching for human text within human text. In full-text search, they have special indexes, and what's important about them is that they know about human language. So they know about plurals. They know that shoes is a plural of shoe and feet is a plural of foot, which is not that trivial when you think about it. English is actually kind of hard on this in this regard. They do, we call this lemmatization, so reduction back to the morphological base unit, the lemma. There's a lot of smarts in there, so they're already kind of aware of human language. And if the user now types shoes, then yes, they will get the product where it says shoe. But if the user types boots, then that product will no longer match because boots and shoes are completely different words. Of course, full-text search doesn't know anything about meaning. It only knows about words and morphology of words. But I think in a normal shop, you actually want to do a search by meaning in general. So if a user comes in and wants boots, and we don't have any boots, we might want to show them shoes, right? Maybe there's a bit of an overlap there. Maybe I need a better example, like shirts and blouses. We want meaning. We want human meaning here. And now you're seeing where this is going. So how do we use vector databases to solve this problem? It's actually pretty easy. All we have to do is we take our product catalog, the descriptions, we vectorize them, shove them in the vector database. When the user comes in, writes boots, we'll vectorize that as well. We search for the topmost three product descriptions in terms of similarity to the user's vector, and we will get stuff with shoes. We'll be doing this in a few minutes. So that's semantic search as opposed to basic full-text search or keyword search or various other kinds of searches. I hope that's clear, and that's already super awesome, and it's great. It's not yet LLM AI though, right? We're not yet doing the really exciting AI stuff, which is why I'm going to say a few words about Retrieval-Augmented Generation, or a RAG. Everybody has maybe heard by this point about RAG. Almost everybody does this. The point of RAG is actually quite simple. LLMs are amazing, but they only know the stuff they were trained on, right? LLMs have not been trained on your company's product catalog. They just don't know it. They also have not been trained on the latest news because at some point they were trained and at that point they're done. They know only what happened up to that point of time. So the frequent problem here is how do we augment an LLM and an AI application with knowledge that it wasn't trained on? That's basically the problem here. Or in other words, we want to attach external memory to an LLM. That's basically what RAG is about. It's very easy. Like these things always sound fancy, and when you actually understand what they mean, it's kind of dumb in the end. It really is. So what we're going to do is, once again, we're going to vectorize your product database and shove it in the vector database. Now, when the user writes their prompt, we can't just forward it into the LLM because the LLM doesn't know anything about our product catalog, right, or anything else. So before this, we're going to vectorize the user's query. We're going to search for the topmost 3 relevant documents in the vector database, and we're going to get out those texts. Now we're going to integrate those things into the prompt alongside, just below the user's query, and that we send into the LLM. In other words, what we've done, we've enriched, we've augmented the user's prompt with relevant contextual information, and by relevant, I mean semantically similar in terms of embeddings and vector databases and all that stuff. Maybe you've heard James Montemagno said this at some point. A main key point of AI, it's all about context, right? It's context, context, context. It's all about that. So this is a way of giving the LLM arbitrary context that's relevant from your company database, knowledge base, whatever is relevant for that query. That's RAG, and practically anybody developing any sort of AI application that needs custom data, that's what you do usually. The alternative is called fine-tuning. There's other ways to go about this sort of thing, but RAG is a very popular way to do things. And in general, any other scenario where you might need to be doing something related to similarity is a great candidate for it. By the way, I'm going to really try hard to get to leave 5 minutes at the end for questions. I really hope I make it. So I'm just going to go through and then keep your questions. And I promise, at the very worst, we'll do that right after the talk outside or whatever. I do want to say a couple words about the types of vector databases that you have when you need to choose one. So the first category of vector databases is what I call dedicated databases. These are products that exist only, or originally only, in order to do vector search. They specifically evolved to answer this problem, to provide a vector search. They're very good at it. These are, I don't know if, has anybody here used one of these, by the way? Yeah, okay, I'm just kind of scoping out the, so these are well known to anybody who has already used vector databases, but otherwise, if you've not done this, these are unknown, because they only really serve this purpose, okay? But once this whole thing AI started taking off and it became apparent that RAG and semantic search are super useful, we now, practically every database out there, any general database like Postgres, SQL Server, but also Mongo or Cosmos, which are not SQL databases, any databases out there has some form of vector search capability because it's so ubiquitous. Everybody needs to do this. Okay, so you've got these 2 categories: the general purpose databases, which have some vector search capacities, and the dedicated databases. In general, just a few words, the dedicated ones will typically go a bit further in terms of the power, the algorithms, the tweakability of the algorithms. That's their only job in life. That's what they concentrate on. They do it really well generally, so they're more flexible. They will allow you more power. And that's a good reason for using them. On the other hand, like there's pros and cons on each side. They're very good at that, but they're much less good at other things. For example, if you also need to do traditional filtering by keyword, by product category, that kind of thing, they're not going to do this very well. Whereas SQL databases, for example, support virtually anything you might want to do in terms of filtering. The dedicated vector databases will not allow you to do this kind of thing. Even more importantly, maybe, if you are adding a dedicated database to your stack, you now have an additional thing you need to manage in your architecture, right? You need to keep it up, so that's a whole DevOps thing right there, right, with high availability and all that stuff. And I think what's really important, you need to find some way to keep that database in sync with your main database. So if you've got a product catalog already in some traditional database, you now have taken on the task of making sure that they're in sync. And when you're adding or deleting products, you have to set up a flow around this, right? So that's actually a good reason, at least when getting started. If you already have something like Postgres, you may want to just give Postgres a try as your vector store. Its vector search capabilities are probably actually sufficient for your needs. If you see that you actually need something more and you actually do need a quadrant or a pinecone, that's a good moment to move. But I would kind of advise at least try, if you have if you already have a database, you're not doing something completely new in greenfield, definitely you should kind of err on the side of not introducing a new thing into your architecture is kind of what I'm trying to say. Okay, I'm almost done with this kind of introductory thing. I am kind of done, actually. So MEVD, Microsoft.Extensions.VectorData. All these databases, both the dedicated and the non-dedicated ones, have their low-level SDKs. So you can use them. You don't need MEVD. That's important. Okay, you always have some way. Maybe you need to just do REST calls to talk to the database. It doesn't really matter. You don't necessarily need an abstraction for doing it. However, in build, we just GA'd just that, an abstraction for dealing with any sort of vector database. We did this at the same time as a sister library called MEAI, Microsoft.Extensions.AI. So these are two packages, two standard .NET packages which contain abstractions for doing things with AI. So MEAI has an abstraction for a chat client. What's up with this? There we go. There's an iChat client abstraction that can be used to talk to any LLM. There's an embedding generation abstraction, which we will use in 2 seconds. And MEVD gives you the vector database abstraction. An analogy that's important here, probably everybody here at some point worked with a SQL database, right? So there's something called system data or ADO.NET in .NET. That's the low-level abstraction that hides away all that abstracts over relational databases. MEVD is the same. It's not exactly the same, but it's similar for doing the same thing for vector databases. So you've got system data for relational SQL databases, and now you also have MEVD to do this with vector databases. Hopefully that's all very clear. I will be talking a bit more about this abstraction and why we need it and what's the point of all this, but I really do want to go into code, so let's just go into code. I'm going to go into Visual Studio. Can everybody see this? I think this should be okay, right? Awesome. Okay, just stop me if you can raise your hand if something is unclear, or if I'm talking too fast, or if this is not readable. Okay, so what I've chosen here is to use Postgres as my target demo here, but that's arbitrary. It's going to look exactly the same for any other database. After all, that's the point of having the abstraction in the first place. So the first thing you're going to see is I'm instantiating something called a Postgres vector store. That's the entry point into our MEVD story. If I F12 into this, then you'll see that I'm in some Postgres vector store, which extends an abstract base class called vector store. That is literally the abstraction or the starting point for the abstraction, right? So everything is going to be extending vector store, and that defines the unified way of dealing with things. Now, since this is a Postgres vector store, the thing I'm giving it as a parameter is a standard run-of-the-mill NPG-SQL connection string. Anybody who uses Postgres in .NET knows this kind of thing. It's very easy. So now we've got our store, which in general represents your database. We have now the database that we can work with. But we now need a specific collection of records. I'm using these words. Don't worry, this will become apparent. A collection is just a collection of records, and every record has the vector and the metadata. I mean, this is all pretty clear. So we're going to get a collection here, and the name is going to be products. Now, since we're doing this on Postgres, this actually maps to a table called products, like a traditional relational table called products, and that's it. And every row in that products table is just going to be a record in this collection. So it's all very, very straightforward. But other databases are not going to be talking about rows and tables. It's a completely different world, right? That's why you have this different terminology here. But in the case of Postgres, it maps really, really easily. So now I'm gonna start getting into the interesting stuff. You can see that when I ask for a collection, I actually get I have to provide 2 type parameters here, which is already kind of weird, right? I mean, should be a bit unexpected. So the first one is the type of the key. Every record here that we put in this collection has a primary key. It's just like relational tables. There's a primary key. That's the thing we're going to use to identify that record in order to delete it or replace it or anything like that. Not very interesting. Can be an int, string, GUID, whatever your database supports. The second one is far more interesting. Here, we're referencing an arbitrary .NET type that I have below here, which represents our idea of a product. And here I'm going to stop for a second. So this is weird, in fact, and we had a lot of discussion around this early on. What you're seeing here is basically that MEVD maps your .NET types directly to the database. In that sense, MEVD is more like EF Core, or maybe Dapper, than it is like system data. System data is a very low-level abstraction that deals with columns and readers and tables. It's very low level, whereas this thing is actually kind of high level. It's somewhere between a very low-level data, like database abstraction layer, and a full-on ORM. It's neither. It's kind of somewhere in the middle, and that's very much by design. That's what we wanted to do, and I'll elaborate on this later. One reason, I'm just going to say a very short thing. With ADO.NET, we kind of abstract over SQL databases, and all SQL databases are kind of similar. They're the same. Their data model is tables and columns and in rows, and that's what the abstraction captures. But vector databases are very wide apart. They're like some have tables and columns, other have like a JSON store, like a document store. Redis has vector search capabilities, so there's really nothing low level we can abstract over because they're too different. So we actually had to go up a little bit in order to capture something and give you an API that's going to be the same. It's kind of interesting how abstractions evolve in general. But back to this code. This is what I actually want to talk about. So this is all fairly standard. We've got an ID, we've got a name, a rating, and we've got the actual vector, which is the whole point of the exercise, right? And I've sprinkled various attributes here. This is a bit like an EF core, where we still have to say various things. It's not enough just to give the type. We have to tell MEVD, hey, this is the key, right? And this here is a data property. This is another data property that I want you to index because we may want to filter by it. And then here's the vector. And by the way, this is the number of dimensions. And that's a thing we have to tell it up front because when it creates the table or the collection, it needs to specify this. So we have to give some schema information, basically. If you hate attributes, some people hate attributes in their data models. Don't be afraid. There's another possibility I'll hopefully show later. So we've now got our collection, and we can finally start doing actual operations here. We're not far away from being done with this hello world sort of thing. So the first thing I'll do is something I do with almost all database demos: drop and create the whole thing. That's a demo thing. I just want it to do this every single time because I don't want to carry state over from the previous run. But of course, the production app will typically not want to drop your database when it's starting up. That's a demo kind of thing. That's fine. And now we're going to actually insert a little bit of data. Let me kick this out of here. So we're inserting 3 products into the database. The IDs don't matter. There's a green shirt, a blue shoes, and a Microsoft Office. You're seeing I'm creating two semantic areas. You're seeing where this is going. It's pretty transparent, I think. There's some rating. I think you're seeing where that's going as well. And finally, there's vectors with totally bogus numbers that I made up. So these numbers absolutely do not represent the meaning of the product in any way. I just made them up and I plugged them in. And we're going to evolve this story, right? I do want to say a couple words. The verb here is upsert. Upsert means insert or update, so it's going to go and see in the database, does this key already exist? If so, it's going to overwrite the record. Otherwise, it's going to insert it. It's a very nice atomic way of not caring about whether I'm inserting or updating. You just want the database state at the end of the operation to be what you want, and that's going to reach it. Interestingly enough, SQL databases don't really usually have an upsert, at least not originally. Like SQL databases have insert and they have update. Upsert is not a thing in the SQL world. So Postgres has it, SQL Server kind of has it, but it's not really atomic. It's all very complicated, actually. But all of the modern vector databases actually have upsert. And that's kind of the more modern way to think about data. So that's what we implemented. I'm just kind of mentioning it. And because I'm a perf person, I absolutely have to say this as well. Because I'm giving a list here, this is going to be a batched upsert. So it's all going to go in one round trip to the database rather than in 3. That's important, at least to me. It's very important. Okay, so we've upserted, we've got some data in our database. Finally, we can get to the heart of this exercise, which is, let me get that out of the way. We've got our similarity search API. It's just called search async. That's the default verb because that's what you want to do with a vector database. And what you're seeing here is I'm going to give it a vector as well. By the way, you're seeing me use a read-only memory. I'm kind of glossing over it. When you see this, how many people here know what a read-only memory is? Yeah, that's a bit low level, right? I know. Okay, so in your mind, forget that this is a read-only memory. This is a float array, basically. All this is an array of floats. A read-only memory is an abstraction over it. I'll say a couple words later if I have time. Just forget about it. You really can replace this with a float array, but for this demo, it's a bit easier for me. Anyway, so again, a bogus number. This is really ridiculous because we have a product here with exactly that thing. So this is not even going to be a similarity search. It's going to be an exact search. That's kind of uninteresting for us, but we're just starting. Another important thing is this top one here. You will notice that if I try to remove this parameter, if I forget it, then we actually get red squigglies because that's a required parameter. And here, this is kind of an interesting thing. Like, why are we forcing you to specify the top? When you do SQL queries, nobody forces you to do limit or top, right? So if you think about similarity, all vectors are similar to some extent, right? They're more or less similar, but they're all similar, right? So if I don't specify a top, logically, I'll always get back the entire database, right? And that's not what anybody ever wants, right? So we force you to explicitly specify the top. You could put int max value if you really do want to download the database. Not a good idea in general. And I have to say, if I were designing SQL today, I would probably force the user to also specify a limit. I would not allow queries without limits because it's a really good idea in general. Like I've seen many performance problems from queries where users just didn't think about it, and then one day you run a query against a huge table which wasn't anticipated, tons of data gets transferred, unanticipated performance problems, and so on. So here we're doing something much more modern, and we force you to do the right thing. That's kind of the intent here. And then if I look at what this actually returns, so the search async method returns an AI async enumerable. That is what allows us to stream results back from the database. That means that if I get back 10 results, I can get the first one and start processing it before I get the second and the third. That's just streaming, right? So again, a very modern .NET API that makes use of all the new stuff. It's really nice to do something like this, like in the future, I'm going to say. This is greenfield. There's no legacy here. You can kind of party and do whatever you want up to a point, because this, by the way, does all support .NET Framework. I'm just going to say there's a lot of people out there still doing .NET Framework, and they should also be able to use vector databases. So it's not a full-on party, but it's a partial party for somebody designing an API like this. And then the vector search result is just a simple wrapper, but what's the important part here is the product. And then I'm just going to do an await for each and print the product's name. So let's run this, and with the help of the demo gods, this will actually work. And yes, we got our blue shoes product as expected, because that's the one that we wanted here, right? Okay, that was my hello world, but now we're going to start evolving this and making this much more interesting. I'm just kind of keeping an eye, and I think we're pretty good for time. So I want to put actual meaning into this and not just have these stupid arbitrary numbers that I plugged in, right? So I'm going to grab a bit of code here from a snippet file I prepared, and I'm going to dump it here. And what you see here, this code is not that interesting. We're going to be using Azure OpenAI, so a service from Azure OpenAI, to do embedding generation. Remember in that slide from before, that's the thing that can take in text, in this case, and give back a vector. And at the end of the day, the important part here, so there's a model here. You have to choose which embedding model you use, and which one you use will have a lot of impact on latency, cost, accuracy. That's a whole thing, like choosing your embedding model, but I'm going to just gloss over it here. And if you look at the return value of this, then you'll see we're getting out something called an embedding generator. That's another new thing. This is something that's part of MEAI. Remember the sister abstraction that we also GA'd at Build. It's just an abstraction for something that gets in something, like a string, and then outputs an embedding. That's basically a new abstraction that we also released this year. And it's pretty cool that we can kind of see all of these AI-related .NET abstractions working together. We'll see them working together even closer very soon. So now, what I will do is, instead of upserting fake data, it's time to insert some real data. So I'm going to do embedding 1 equals. Let's see, so AI didn't exactly do its job because these are very new APIs. It hasn't been trained on them. Maybe it needs some RAG. So I'm going to be generating the embedding. I need 2 other embeddings here, I think, and hopefully autocomplete is going to help me out. And yes, it does, which is pretty cool. I'm going to go and replace these fake embeddings. Thank you very much, Copilot. Sometimes it actually does work. I'm just kidding, right? And then obviously, I also need to generate an embedding for the query itself. So let's go. Everybody's rooting for some sort of demo fail here, I know. Hopefully that doesn't happen. I'm going to actually reproduce like my scenario from before. So I'm going to be searching for boots, although there's no boots in my catalog, but there are shoes and shirts, okay? I'm also going to change the top here to get me back 3 products, or my entire product catalog in this very small catalog. And it's going to be interesting to see what actually comes back. Now I'm going to run this, and I think I'm going to maybe see a failure. Let's see if I remember things correctly. I am seeing a failure. So what's the failure here? Right, Postgres is telling me, this is a Postgres error, it expected 3 dimensions, but it got 1536. Where are these numbers coming from, right? So anybody who uses a little bit of embedding generator, so 1536 is simply what the embedding model returns. That's sort of a standard number anyway. Everybody who's in the field knows it. So the dimensions we get back from Azure OpenAI are 1536. But we configured, remember, our dimensions here to be 3. So that's the error. Let's adjust this and go on and run this again. In fact, what I'm going to do just for fun, I'm going to place a breakpoint here so we can see the actual embedding coming back out, just to give you guys like some tangible idea of what an embedding looks like. So if I look at embedding 1, you can see there's like a bunch of numbers here, which mean absolutely nothing at all to us. It's an opaque string of numbers that does something, basically, represents the meaning. But now hopefully if I run this, and I continue, then what we see here is the 3 products. Interesting, this is not what happened to me in my demo. So we did get blue shoes, which is good, but somehow it decided that Microsoft Office is a bit more relevant here than the green shirt, which I would say is a bit of a fail, right? But AI demos are great because you do something 1 minute before and then you get some different results because it's all non-deterministic, right? It's all great fun and games. Okay, so this is now starting to look like an actual application, right? Because we're actually generating real embeddings with real meaning, and we've done actual human meaning-based similarity search here. For me, by the way, like 10 years ago, this is rocket science. This is like the future, and I just did it like now. It's really amazing when you think about it. Like the computer knows about our meaning suddenly, all of a sudden. Okay. Now we're going to go back to the abstraction. So when I look at this code, this whole thing here, these details about I'm going to get the text, and I'm going to pass it through some abstraction, and I'm going to get the vectors back, and then I'm going to insert those vectors, that's all very low level. Nobody actually wants to deal with these arrays of floats, right? They're uninteresting. They're low-level representations. So when I was thinking about this thing, I kind of thought, this is something we need to take care of for the user. Users should not need to deal with embedding generation in that way, in that manual way. And so we're going to be doing this now. What we did is we built the following capability. When you create your store, you can also pass in an option bag, so you can tweak it, configure it in various ways. And one way to configure it is to make it aware of our embedding generator. Let's see, I think I forgot my parenthesis here. So importantly, MEVD is now aware of MEAI. It is aware of the embedding generator. This is an integration between the 2 completely separate packages, which are AI related and which came out at around the same time. It's super cool. What does it do? The important thing, this allows us to do the following thing. I'm going to scroll down here, and instead of having this ugly float array, which is very low level with all the numbers, I'm just going to stick a string here. This is what we actually want to work with, right? Like what we have in our product catalog is strings. It's not floats. What we really want in our modeling is to just have the string in there, right? So once we put the string in here, now we, of course, can get rid of this shitty code. And now it's going to look a little bit duplicated, but that's OK, at least for now. I'm going to go here, and I'm going to just duplicate it with the help of Copilot. There we go. And in our query as well, this starts to look really nice. I'm going to just search for boots. And if I run this, hopefully, with the help of the demo gods, we're going to see the exact same result. Maybe even Microsoft Office is still in second place, but that's OK. So we've simplified our code. And what's happening here under the hood that's important is that MEVD is looking at our model, and it sees that this is flagged as our vector property, but the type here is a string. It's not an array of floats. That's not a natively supported thing, right? Embeddings are a vector, but string is not a vector, right? So it understands that what we want is for it to take care of embedding generation. And since we've configured it with an embedding generator right here, it will automatically and transparently perform embedding generation for us. So we've just pushed that concern into the ORM or the data access layer, whatever it is you want to call this, or into the abstraction. And every time I do the upsert, it will actually take the string and it will call out into the embedding service to do everything. Because I care about perf, it will also do a batched call to Azure OpenAI and give it the 3 embeddings so that we don't have to do 3 round trips as well. So this is batching all the way. That's kind of important in the design of this kind of thing. Okay? So hopefully this is already pretty persuasive in terms of, it's really the simplest way I can imagine that somebody might want to use it. There's a little bit here around the duplication, but I'm gonna skip over it because I'm not sure I'm gonna have enough time for all the other interesting stuff. There's one more thing I wanna really go over before we go back to some conceptual stuff to the presentation. So I mentioned before that very, very frequently you wanna also have some sort of traditional search filtering before the similarity search. For example, you might want to search only within a specific product category for apparel. Or maybe you want to only search for highly rated products, right? You want to have some old school SQL-like where clause on this thing in addition to the similarity search, which is only about the ordering of the results. And of course, all vector databases support this because it's very, very common, right? But they all support it in very different ways. So if I actually went and implemented around 12 implementations of this thing, I really know all there is to know about all the different interfaces of all vector databases. Believe me, it was not fun to do this for 12 databases, but they all have wildly divergent ways to express filters. SQL databases have a where clause, and everybody knows this, but some other database like Quadrant is gRPC based, and you will send an actual gRPC data model that represents your filter. Very different, like very, very different. So how do we abstract over a query language? Does anybody have any idea? In .NET, how one abstracts over a query language? Yes, very good. Good answer. .NET has an amazing thing called link, and anybody who's used the if core has already abstracted over query languages by using link. Link allows us to write C# code and have somebody else translate it to whatever is necessary in that database. So we're going to basically do the same thing. I'm going to go to the search here. And like before, you can pass in an option bag to tweak the search. There's various tweakability things, and I'm going to do filter. And here, that's a nice attempt by Copilot, but it's wrong. It wants us to put in a string, and that would suck, right? Like, who wants a string? If it's a string, that means that when I refactor and rename my properties, then things get broken. We don't like that in .NET. We're a strongly typed language. So instead, I am going to assign, and now it got the hint. So I'm going to use C# code. This is exactly like EF Core. It's exactly the same. It's not fully if core. You don't have operators like where and order by and take and skip, but you do have the thing that is inside the where, right? That's basically that. It's the same lambda. So you use C#, plain old C#, strongly typed, and we will take care of translating that to whatever your database wants. And now at this point, if I run this, hopefully we see different results. Right. The blue, whatever it is, the shoes, which were first in line, disappeared. Why? Well, you guessed it. It's because their rating is too low. That's how that's the blue shoes. That's how I engineer this, this example, right? So we basically did a pre-filter that allows us to select what we want for the similarity search. And link is awesome. Like, I personally really love that we could just use link in this way, and it's really the correct solution to this. On the other hand, note that you can put any valid C# code in here. Whether that works at runtime on your database is another question. And if you do like some arbitrary thing, it will simply not work. You will get an exception saying, yeah, we don't support this. Here, you also should not accept the sort of power that you have with EF Core when running on SQL databases. So vector databases are very limited. The dedicated vector databases typically support like this kind of thing. They support Boolean operators like and or and not, and a little bit of comparisons, and there's a bit of features here and there, but that's about it. There's no like a huge catalog of functions like in SQL that you can call and so on. So this is a very, very constrained sort of scenario. And if you start partying here, you'll just get a runtime exception. But still, using link here is kind of like the amazing solution to the problem, at least in my opinion. Just be careful and don't think that just because it's C# code, you can write absolutely anything. It still has to be translated to something that's supported by your database provider. That's how this thing works. Okay. I think I just want to do one more note on this before I go back to the presentation, but I'm going to go fast. So what you've seen here is that we're mapping a .NET type, right, this product, but that doesn't fit for everybody. Like this is the EF Core mode, right, where you have a strongly typed schema, you know what your product looks like, and everything is kind of set in stone. Sometimes more advanced usages need something a bit more dynamic, especially if you want to be writing a layer on top of this that's going to be generic, that can be used for any sort of data model. So we also built, I'm going to do this super quickly here. Let's just go to another branch here, doing this the old style way, because I'm an old school guy. So I went to a branch where things are very similar, but still we're now using something called a dynamic collection. We no longer have the product here, so I've commented the product out. And instead of having instances of product, we now have dictionary of string to object. So we've basically gone dynamic now, and a dictionary of string to object is what represents a single record or a single product. In this mode, we still have to provide some schema information. Of course, we can't do that via attributes anymore because there is no type, which is why we have the same information here. So this is not dynamic in the sense that there is no schema. There is still a schema, but you don't have a .NET type that kind of nails it down. And this allows for various sorts of third-party layers to be built on top, and I'm going to say a few words about this. And I'll also mention, how many people here are using native AOT to some extent? Any extent? Okay, one and a half. Okay. Anyway, native AOT is important to me. It's important to .NET. It's still in early stages, so not everything in the ecosystem supports it, which is why it's also not always possible to use it. But it's very important for new stuff to support native AOT, so we don't go backwards in terms of support. So if you use this dynamic mode, then we're 100% compatible with native AOT from the get-go. For the other EF core mode, because there's .NET types involved, we're not there yet. But that's firmly on the plan. So a source generator that's going to do all the stuff that's needed for this sort of serialization scenario. Right. That's kind of like the set of features that I wanted to show. I do want to do a quick recap of what we saw, just so that you guys have a clear, yeah, sorry, this is kind of bright, just so that you guys have a good summary of what we saw. So MEVD allows you to do either .NET POCO mapping, so map your .NET types, or it allows you to do dynamic via dictionary, and the latter is native AOT compatible as well. Eventually, the POCO one will be compatible as well, but actually, we need you to tell us. So if it's important for you that we do the native AOT thing, if it's more urgent, then please tell me about it so that I can know and maybe we prioritize it. We also have this very cool embedding generation integration with MEAI, which allows you to not care about the whole process. I really like that the only place where you deal with embedding generation is at the top of your program. When you set things up at setup time, obviously you need to say, I'm using Azure OpenAI, and I'm using this model, and here's my credentials. Like, you need to specify this somewhere, but you do this only in the very beginning. Once that's all set up, and by the way, there's a really nice DI story. This is not a DI demo, but there's a really nice DI story to this as well. It integrates really well into DI programs. You only do this in DI, and then your actual program code looks like it's completely free of thinking about embeddings, and that I really like. I'll also say that this, I think, is probably something you will not find in other languages in general. So if you go and use a vector database in Java or whatever, usually you don't see this sort of really nice integration between different layers where we've got a universal abstraction for embedding generator, we've got a universal abstraction for vector database access, and they interact with one another. That's like a really cool part of doing this in .NET. We've got link-based filtering, which is super cool as well. It gives you a much nicer kind of experience. That you will also not find in other languages because they don't have link generally, right? Python has something like this, but anyway, that's another kind of nice thing. Just honorable mentions for stuff I didn't have time. There's something called hybrid search, which is a very overloaded term. It turns out it frequently makes sense to both combine vector search, what we saw, which is based on meaning, and traditional full-text search, which is based on the words, right? Like the wording kind of thing, like the shoe and shoes sort of search that I mentioned before. It makes sense to search both by meaning and by full-text search, and then combine the results together via something called reverse reciprocal fusion, RRF. I hope I'm getting the name of the function right. Anyway, there's ways to combine searches. This is all very, very popular at the moment. So there's full first-class support in the abstraction for this, even though not all databases support it. We also allow for just traditional filter-only searching without similarity search. That's useful for data management things. Anyway, I'm not going to go too much into it. Okay, I've got exactly the amount of time that I kind of wanted. I do want to go a bit more conceptual just to close out this talk because we're nearing the end. So I glossed over this at the beginning, but the question is like, why do we need an abstraction in the first place? Like sometimes, like I used to work on Java, by the way, and Java really loved abstractions at a certain point. They abstracted over absolutely everything, and sometimes I was kind of like unsure, what is the point of having an abstraction here even, right? So there's several responses to this. The first one I like I'm going to order these by how much I like the responses. I'm going to do it like that. So the first one is that abstractions allow us to build generic components on top, which can work against any vector database. And this is the point to mention. We're right now actively working on something on top called a data ingestion framework. I don't know if there's a name for it. What that basically means is, so you can access your vector database thanks to MEVD, but what you really want usually is a whole pipeline which takes, let's say, all your PDFs in your company SharePoint or whatever product catalog, like basically takes all your documents, extracts text out of them. Like if it's a PDF, you need to somehow get the text out, chunks them into smaller pieces, maybe removes out the PII, personally identifiable, like sanitizes the data, maybe summarizes it to kind of condense it, and then after chunking it to smaller pieces, vectorize and shove it into the database. That's a pipeline, what I just described. It's a whole thing that needs to happen on a permanent basis in your, presumably in your company, right? As data flows into the vector database, right? And then gets queried from the other side by users. So something like that, you can't develop without some sort of abstraction over vector databases, right? And in fact, if you look at Python, if you look at Llama Index, or you look at Spring AI in the Java world, usually you have some sort of vector database abstraction as part of that product that does a pipeline, okay, that does something of the sort. In .NET, the cool thing is that this abstraction is now not part of a specific product. It's part of .NET itself. So it's one universal way to deal with vector databases as opposed to something that belongs to a product. Historically, by the way, this thing was born inside semantic kernel. So we went through the same path as the other languages. This was born really out of a need in a specific product that does AI stuff. But then we looked at it and we said, wait, there's a potential here. This is actually a universal concern. And that's a thing I really like about .NET. Because it's a universal concern, we're going to extract it out of this product, and we're going to make a general thing. It's under Microsoft Extensions. That makes it the thing, like the officially endorsed .NET way to do it, and it has all the provider implementations and so on and so forth. So look forward, like, I don't know exactly when this is going to get released, but I'm pretty sure that in .NET Conf, there's going to be some sort of preview of a data ingestion framework, and that would not be possible without something like MEVD. So that's the first reason to have an abstraction in the first place, is that you can build stuff on top, okay? The second one is that MEVD provides a higher level experience than what the SDKs provide. The SDKs are very low level, like they really require you to deal with do a lot of serialization and handle all kinds of crap. Here, we actually allow you to map .NET types. That's very high level. As I said in the beginning, it's a bit like an ORM. The link abstraction here is the same kind of thing. You don't need to learn any sort of specific query language because we do the heavy lifting for you, right? Now we're getting into the domain of me not liking so much, but it is still there. So the SDKs, it also turns out, are sometimes just not very good. They're not very idiomatic for .NET users. For example, in many cases, the SDKs for something like Quadrant are simply auto-generated from protobuf contracts, right? So you take a protobuf gRPC kind of contract, you generate C# out of it. It sounds great, but you get something that's really, really bad in terms of a .NET experience. It doesn't look like a nice API that developers want to use. And so we got a lot of signal from people saying, I don't want to use this crappy thing. Build something nicer for us. I don't think that somebody should need to use an abstraction just because the low-level thing doesn't look good. The low-level thing should look better. That's what I think. But anyway, it is the world that we live in sometimes. So we kind of taper over shortcomings in the lower layers. And then the last one, which I really kind of don't like, and this is a very old sort of debate. Some people say, oh, I'm going to use the abstraction because it allows me to swap out my database. I'm going to start with this database, but maybe in a year we make a decision that we want to move to another database, and then it's going to be a flawless transition because you've given us an abstraction. I see smiles in the crowd. That's good. That's very good, in fact. Anybody who actually uses databases knows that this is an illusion. You cannot abstract over databases. All abstractions, I want to say almost all abstractions in general, but specifically abstractions for databases are leaky, and they're leaky by design. It's not that they were badly designed. Databases simply are very different products with different capabilities. For example, the list of data types between Postgres and SQL Server and the dedicated vector databases is completely different. Quadrant only supports GUID and ULong as keys, no string keys. Why? I don't know. That's just the way it is. So if you try to migrate from Postgres to Quadrant and you have a string key, yeah, you're going to have to change things. It just doesn't work. So it does help. Obviously, if you have an abstraction and you're going to be switching around, yes, it's going to reduce the amount of work, but you should not be planning for switching a database maybe in the future, right? That's not the way that these things should work. This was a popular discussion 20 years ago, like ORMs are there in order to abstract over the database and we can switch them around. I'm not sure. Okay. The very last thing, and after this I'm going to stop for Q&A. So the sort of elephant in the room, at least for me, is what's up with Entity Framework and all this. So I'm talking about data and databases, and there's already EF Core. EF Core, also in my other hat, I actually did a ton of work in the last year to make sure that EF Core works great for vector search as well. So I've worked on vector search actually in two completely different stacks. MEVD is one, EF Core is another. They're not really connected, and that's also by design. That's not a mistake. In EF Core, you can simply take your blogs, your DB set, and then you can order by EF functions vector distance, which is simply the way to translate to the SQL Server vector distance function. You give it the similarity measures, cosine similarity, and the two vectors. Take 3, that gives us the top, and then to list async. The Postgres one looks almost identical. There's just a bit of difference here in how you specify the function. So what's up? Like, when should you use which one? So I'm going to say it like this. First of all, most of the embedding, basically all of the dedicated databases are not suitable for EF Core. EF Core is not for those kinds of databases. Sorry, I keep saying that. The specialized ones like Quadrant and Milvus are very, very specialized. They know how to do one thing well, and they don't have arbitrary querying capabilities. So for one thing, it's not possible for us to translate arbitrary link operators when targeting those databases. They just don't support arbitrary querying in general, right? So then there is no way to use them from EF Core. It simply doesn't make sense. If you're using something like Quadrant or Pinecone or Weaviate, you cannot use EF Core. We don't support it, and we most probably won't. What you can do is use either the low-level SDK for that database or MEVD. On the other hand, if you're already using SQL Server or Postgres or Cosmos or Mongo or any one of those databases, and you want to now, in addition, start to use vector search, then this is perfect for you. And that would be my recommendation. If you already are on EF Core, my goal is that you can continue using EF Core in order to do your vector search in the data that's already in your database. But the moment you step out and you've decided to take the plunge and go with a dedicated database, then you're out of the EF Core story, because it just doesn't match very well. So we do really have two stacks or ways to do vector similarity search in .NET, and that's okay. There doesn't necessarily have to be only one. And by the way, I'm just saying, one of the big kind of areas of focus for EF11 is to make vector search and vector mapping better in EF itself. So MEVD is kind of further along now compared to EF Core. I think that's about it. This is now closing words. So there's 12 implementations currently which you can use. I've listed these here. Anybody can implement another provider, and you can also ask for them, and maybe we'll implement it for you. This is very new technology, so the abstraction itself GA'd only a few months ago at Build. The implementations themselves are actually still in preview, but this is something that I'm actively kind of going to work in, like maybe starting from next week, right? So be prepared that this is a little bit new, like everything with AI, everything here is a little bit new, so there might be a bit of shakiness. There's also a bit of confusion. The abstraction is now Microsoft.Extensions.VectorData, MEVD. The implementations, though, are still under the semantic kernel namespace. That doesn't mean that you're using semantic kernel. So if you use the semantic kernel provider for SQL Server, that's all you're using is a provider for SQL Server. You're not kind of looping in, bringing in the whole semantic kernel sort of stack. Even though it looks that way, it's a confusing state of affairs, and I wish it had a different naming, but it is what it is. But don't be deterred just because it has semantic kernel in the name. Yeah, look forward to the data ingestion thing that's going to be built on top. And I really like seeing this, this set of abstractions getting built up and the whole stack of AI things in .NET. That kind of, I find that very exciting and cool. And with that, I think we've reached the end of the talk. If you want to see, so the samples are here. You can take a picture and take a look at the GitHub repo. There's the two branches there. There's like the main and the dynamic branch where you can see the code here. Hopefully this was useful and you learned new stuff. I think we might we still have like a minute and a half for questions. That's not as much as I hoped for. Any questions? Like, please don't be shy. It's a small crowd anyway. There's no need to be shy. Please. A scenario where you have what? Sorry? A legacy product database. Yes. That you cannot just add a new vector column. Is it possible to do the semantic search at runtime if cost is not an issue? So in theory, very much in theory. And why not? Right. So the thing is, like, for any real life usage, you want to generate the embeddings. That's an expensive process, so you want to generate them and store them somewhere. And I would say if you can't add a column to your database, maybe you can add a table and have some sort of foreign key relationship and just store the embeddings there. It's basically the same. It's almost the same thing. Or if you really can't touch your database at all, yeah, maybe install one of the dedicated products that I said here, like have a completely separate database and then set up some sort of sync between them. Like that would be that's the real answer to your question. In theory, like very much in theory, when somebody does a query, you could generate the embeddings and then go over them and something. But I mean, if your database is very small, maybe that makes sense. It's not an actual solution. Like you have to have some place to persist your embeddings, like in some area, shape, or form, basically. Like there are some cases where you are able, if you have a very small and static sort of database, maybe you can generate the embeddings once, dump them to disk, and then load them into memory, and then do the semantic search in memory. You can absolutely do vector similarity search in memory, and there's libraries for it, no problem. But that's not going to scale, like, at all. I hope that answers the question. Come talk to me afterwards if you want to. Any other questions? Yes, and I think that's going to be the last one. Who has a model? Sorry? Well, there was like an embedding string, right? The embedding, like the name of the model? Yeah. These are, I need, okay. Let's take this. So that's just a static name of a model that you will see in the Azure OpenAI kind of thing. It's magic strings. That's all that it is. You don't have to worry about that too much. Let's go outside, and thank you all for coming to my talk. Tomorrow as well for a radically different kind of talk, like completely unrelated.